Okay, so this is section 4.6, but to do section 4.6, we have to go back to 4.1 and take a look at that. And in 4.1, they talked about this idea of earning power. And so the notion of earning power is your dollars, the dollars that you make. Now, technically you got to be a little careful there because you want to do it in relative dollars because prices go up usually each year. That's just the way life seems to work. But in their motivating example, they look at earning power of men and women. And so they have year, and they have 1970 and 1987. And so for women, their average earnings were 5616 in 1970 and 531 in 1987. And for men, year 1970, 1987, and so we have 9,521 and 28,313. Okay, so they give those data, and they ask, how can we predict the future earning power of women and men? So they're really just saying, okay, if we look at these trends, what can we see? And so they plot it here, where this is year and this is dollars. And they plotted point here, so this was 1970, 1987, and something up here, and so this was the 5616, and this was the 18,531, and then similarly you could have year, dollars, 1970, 1987, and obviously these two scales are not the same, so there's 9521 and 28,313, and we see that, and they're both points, both two sets of points, and so the question is, well, how do we predict what happens in the future? And one way to predict that, so this was that motivating example, is, well, let's assume everything goes on a straight line. Then where do things end up on the straight line, and can we take care of that algebraically? And so they determine equations for those. But let me go to 4.6, kind of looking at things right now. And yeah, so they kind of look at the two ideas now. So, okay, so now we're at 4.6, and okay, so they in 4.6, they're just modeling the men's earning power first, and so you know, they want to look at kind of using this prediction, so using the answer. Okay, so for men, we had our 2 points here. So we had a point of 1970 and 9521. So notice I dropped the comma there because it would just get confusing with that other comma. And another point of 1987 and 28,313. Okay, so we can get our slope here. So M is 28,313 minus 9521 divided by 1987 and minus 1970. And so we get the first one, 18,792 divided by 17. So that's our slope. And then we can use that point slope form and say that y and equals 18,792 over 17 times x, and at either point will do. I'll use the first one just as they did, minus 1970, and then plus its corresponding y value, 9521. Now, you really should then, I mean, here, never have I told you exactly, you know, what x and y was, and then I used a y here that seems a lot like year, right? And so I should really say where x is year and y is dollars. Okay, or average dollars earned or something along those lines. So let me try to get that, well, there we go. Okay, so that is our equation for this thing, and what we'd like to do is determine what the earning power is in 1995. Okay, so earning power in 1995. Well, at this point, we have a nice functional relationship of our dollars as a function of year. And so I can just put that in as x, right? So x equals 1995. Now, so algebraically, I get that my new y should be, I had to look at the numbers there, 18,792 over 17 times 1995 minus 1970 plus 9521. Now, they tell me in the textbook that that is 37,156. Okay, so there is our algebraic language. Now, graphically, though, what I should be able to do is, you know, here's x, year. Here's y, dollars. If I take those 1970, 1987, 1995, this is not really quite drawn to scale, but, and what was this again? This was somewhere back here, 9521. And 18,792. So we had those points, and we had that graphically. Well, we assumed a straight line, and so if we come up here straight up and we find that point, then what we should find is that this is 37,156. Okay, so there is the graphical representation. So graphical and symbolic. And then, of course, in English, what we've determined is that the earning power projected for men in 1995 is $37,156. Okay, so there's English. And again, you want to be fluent in all those, that if you see something like this going on and these kinds of questions in English, that you know, you can think of graphically how it's represented, and you know how we write these in English, and how we work with them symbolically. So you want to be able to work on all of those. Okay. And then, you know, they ask, you know, for a next question. Fighting with this thing a little bit. Okay, another question is, well, when is the earning power $33,000? Okay, well, so when you know, we're told, as we think about this, we're told y is equal to 33,000. What is x? Well, we have a relationship, so symbolically again, we have our relationship. Remember that y is equal to 18,000? Is that what it was? Yeah, 18,792. Oh, sorry, I drew this wrong back here. Let me fix that. This was 28,000. I read the wrong number, I guess. There, I needed that number. Sorry about that. So if you were wondering what was going on there, well, I screwed up. 313. Okay. So that should have been that point here with this one. Now, okay, so let's try that again. 18, well, of course, now I forget the number. 18,792. 18,792 over 17 is x minus 5,912? No, 905. 9,521. Having troubles. Not good with numbers. Okay, so 9,521. And then plus the 28,000, whatever the heck I just said, 28,313. Boy, am I having trouble. Let me try that again. Sorry about that. I just forgot where I was at. So we had x minus 1970. Sorry, the year. See, you know, I can get things wrong. I do it all the time, actually. But Again, I think I've mentioned this before. I don't mind you seeing me get things wrong because the point is, typically I find them. And, so sure, you get a lot of stuff wrong when you write lots of numbers and write lots of things all the time. And um, at least that's what I find is the more opportunity you have to get things wrong, well, the more things you will get wrong. And so I do get things wrong, but I catch them. Why? Because I don't just blindly put it down. I put it down, I think about it, I look back at things, I think about, as I'm going on, I think about it. Um, and so, the idea is keep thinking. And so now I need my 9,521. 9,521. Okay, that was the dollars. And okay, whew, sorry about that. Uh, so that's our relationship. And now what we know is that y is 33,000. We still have our 18,792 over 17, x minus 1970 plus 9521. So we end up with this relationship, and here's an equation we need to solve. So this is where equations come from. We had one equation involving two variables that was our relationship between the two variables, the year and the earning power. But then if we either know the earning power or the year in which we're interested, then we get a new equation that involves just one unknown variable, and we may want to solve that equation. And so we do. And now, typically, I like to have, the stuff involving the variable on the right-hand side. So, I personally would, write this way. And part of the idea is, like I just said, I make plenty of mistakes. Well, one of the ways I've found to cut down on my mistakes is to try to use the same process every time. So if I'm used to having my unknown on the left-hand side, I like to start it that way. So now I'm going to subtract the um, 9521 from both sides. So I end up with 18,792 over 17, x minus 1970 equals, I guess this would be 32,048, I think. And then x minus 1970 equals, now I'll just multiply through by the reciprocal of this thing. And so I've got 17 over 18,792 times the 32,048. And then I get x equals, that's 17 times 32,048 divided by 18,792 plus 1970 when I add 1970 to both sides. Now, if I did this correctly, it should evaluate to 1991.24. Okay, so I interpret this as sometime, now about a quarter of the way through the year, but we'll say sometime in 1991, the earning power was or would be $33,000. Okay, so I interpret my answer. And again, I could say, basically around the end of March, right? Because that would be a fourth of the way through the year. So the end of March. Okay, maybe. And um, and there we go. Now, again, graphically, in this case, what we have is, again, we had our 1970, we had our 1987, we had our 9,521, we had our 28,000 and something or other. Okay, and we were assuming a straight line like that. And then we said, okay, well, we know we're at 33,000, so let's look over here and look down. And what we found was, 1991 was probably about right there, 1992 about there. And, so graphically, again, this is our answer. So we have our graphical representation. Up here we had our symbolic. Oops, symbolic. Okay, and you want to just keep thinking about that the whole time as we've got English. Okay, we've got English. We've got symbolic language, and we've got graphical language. And so, we can look at these two things. Now, at the very end of the section, they ask, are women gaining? Well, okay. So graphically, I can interpret that as, well, we know the men's line, whoa, I don't know what I just did there, but probably got you dizzy. So the men's line is up here, and I'll tell you this right now in this video, my family is making disparaging remarks about your teacher. So, sorry about that. They're probably warranted, but, now the question they're asking is, does the women's line, we know it's lower, but is it gaining like that? So here's a question, is it doing that? Or is it doing that? They're still talking disparagingly about me, but that's okay. Okay, so, that's the question. And notice it's really about a question I can see here very quickly. It's about the slope. Okay, and so we know, we'll try to get this to work again. Okay, there we go. We know men's slope is whatever it was. Now I don't remember. Let's see. 18,792. 18,792 over 17. Women's slope is, and let's see, the women's slope, I guess they give us as 12,915 over 17. Okay. And so, as you look at this, the men's, so men's slope, is greater than the women's slope. Oops, I should use an M there. Okay, so MW. And so, unfortunately, the answer, according to this, under this model, is no, not making gains, because again, we can turn our question just by looking at the graphical interpretation. We see that it really just comes down to slope. And and so there's a slope for the men, slope for the women. And so the men are still making gains. According to this, the earning power under this model, the earning power of men is growing compared to women. Now, I have no idea if their data are correct or anything like that. So I don't know the truth of this, let alone whether using a straight line model is the best idea. But under all these conditions, yes, the answer would be no. Um, Women are not making gains. Okay. And so that takes care of 4.6.